Right now, there's a crisis brewing in the shadows of Silicon Valley that nobody's talking about. While everyone's obsessing over the latest AI models and which company will dominate the chatbot wars, there's a fundamental problem that could bring this entire revolution to its knees. It's not about compute power or data quality or even regulation. It's about something far more basic, something we've taken for granted for decades: power. The artificial intelligence boom has created an energy appetite unlike anything we've ever seen. These aren't your grandfather's servers, sitting quietly in a corner, sipping electricity like a laptop on standby. Modern AI training clusters are absolute monsters, devouring electricity at a rate that would make your local steel mill blush. And here's the kicker: our electrical grid was never designed for this. I'm talking about $1 trillion reshuffling of the entire energy landscape, where the winners and losers will be decided not by who has the best algorithms or the smartest engineers, but by who can solve the most fundamental challenge of all: keeping the lights on. In the next 10 minutes, I'm going to break down exactly what's driving this unprecedented power crunch, reveal which industries are positioned to win big from this energy gold rush, and walk you through 3 scenarios that will determine who controls the future of artificial intelligence. Because here's what most people don't realize: if energy becomes the new bottleneck for AI development, then energy companies might just become more valuable than the tech giants themselves. But first, let me paint you a picture of just how insane this power demand really is. When we talk about artificial intelligence, we're really talking about 2 distinct phases that each have radically different energy requirements. The first is training, where massive models learn from enormous datasets by running calculations across thousands of specialized chips for weeks or even months. Think of this as the equivalent of teaching a human everything they need to know about a subject by having them read every book ever written on the topic, except they're doing it at superhuman speed. The second phase is inference, where that trained model actually answers questions or generates content. This is like the human, using everything they've learned to have a conversation. Now, you might think inference would be the lighter load, since it's just using knowledge that's already been acquired. But here's where things get interesting. A single AI training rack can consume as much power as several hundred homes. We're talking about 40 to 80 kilowatts per rack, compared to maybe 5 to 15 kilowatts for traditional server racks. But the real shock comes when you scale this up. A single large language model training run can consume as much electricity as a small city uses in an entire month, and that's just training. The inference side is where things get truly wild, because that's where the scale explodes. Every time someone asks ChatGPT a question, every time an AI helps write an email or generates an image, that's an inference request. And with billions of people around the world starting to integrate AI into their daily workflows, the cumulative power demand from inference is projected to dwarf even the massive training requirements. According to recent industry projections, data center electricity consumption could triple by 2030, with artificial intelligence accounting for the vast majority of that growth. We're looking at an additional 200 to 300 terawatt hours of annual electricity demand just from AI workloads. To put that in perspective, that's roughly equivalent to the entire annual electricity consumption of Argentina or South Africa. But here's where the story gets really interesting. You might be thinking, sure, chips are getting more efficient all the time, so won't that solve the problem? Moore's Law and all that good stuff should keep power consumption in check, right? Wrong. While individual chips are indeed becoming more efficient at performing calculations, the scale of AI deployment is growing exponentially faster than efficiency improvements can keep up. It's like trying to empty a bathtub with a teaspoon while someone's filling it with a fire hose. The efficiency gains are real, but they're being completely overwhelmed by the sheer volume of new applications and use cases. Every major tech company is racing to integrate AI into every product they make. Your smartphone will soon have AI processing happening locally. Your car will be running AI models for everything from navigation to voice recognition. Your smart home devices, your work applications, your entertainment systems. The number of AI inference requests happening globally is set to grow by orders of magnitude over the next few years. And this is where our electrical grid runs into a brick wall. Our power infrastructure wasn't built for this kind of concentrated, high-intensity demand. Most electrical grids were designed around the assumption that power consumption would be relatively distributed and predictable. A little bit here for residential use, some more there for commercial buildings, and larger chunks for traditional industrial operations like manufacturing plants. But AI data centers represent something entirely new. Massive point loads that can exceed 100 megawatts at a single location. To put that in context, that's enough power for roughly 75,000 homes, all concentrated in a single facility that might occupy just a few city blocks. The bottlenecks are everywhere you look. Electrical substations that step down high-voltage transmission lines to lower voltages suitable for data centers have waiting lists that stretch years into the future. The specialized transformers needed for these installations have lead times that can exceed 18 months. And that's assuming you can even get the permits to build in the first place. Then there's the transmission infrastructure itself. Moving massive amounts of electricity from where it's generated to where these data centers need to be located requires high-voltage transmission lines that can take a decade or more to plan, approve, and construct. The regulatory approval process alone can stretch for years, involving multiple states and federal agencies. Some of the hottest markets for data center development are already hitting hard limits. Northern Virginia, which hosts a huge percentage of the world's internet infrastructure, is seeing power constraints that are forcing companies to look elsewhere. Texas, despite its massive electricity generation capacity, is struggling with transmission bottlenecks. Phoenix and other southwestern cities are grappling with the reality that their electrical infrastructure simply wasn't sized for the kinds of loads that modern AI facilities require. And here's the really crazy part. You can order and receive cutting-edge AI chips in a matter of months, but getting the electrical infrastructure to power them can take years. It's like being able to buy a Ferrari, but having to wait half a decade for someone to build the road you need to drive it on. This mismatch between the speed of technological development and the pace of infrastructure deployment is creating the most significant constraint on AI development that the industry has ever faced. And it's opening up opportunities for entirely new categories of winners while threatening to derail the plans of some of today's biggest players. The companies that figure out how to navigate this energy maze won't just survive the next phase of AI development, they'll dominate it. So who exactly wins when energy becomes the new battleground for AI supremacy? The answer isn't as straightforward as you might think, because this crisis is creating winners and losers across multiple industries simultaneously. Let me walk you through the major players and what this energy crunch means for each of them. First up, the utilities. These are the companies that own the power lines, the substations, and the distribution networks that actually deliver electricity to data centers. And right now, they're sitting in the driver's seat. For decades, utilities have been dealing with flat or declining electricity demand as homes and businesses became more energy efficient. Suddenly, they're looking at unprecedented demand growth that could last for decades. The biggest winners here are utilities in regions where data centers are clustering. Companies like Dominion Energy in Virginia, American Electric Power in Ohio, and Duke Energy across the Carolinas are seeing demand projections that would have been unthinkable just 5 years ago. They're signing power purchase agreements with tech companies that lock in revenue streams for 15, 20, even 30 years at premium rates. But utilities aren't just benefiting from higher demand. They're also able to justify massive infrastructure investments that regulators previously might have questioned. Need to build a new transmission line? Well, it's for AI development and economic growth. Want to upgrade substations? Same story. The AI boom has given utilities a blank check to modernize their infrastructure, and they're passing those costs on to ratepayers. Next, we have power generators, and this is where things get really interesting. The companies that actually produce electricity are seeing opportunities they haven't had in years. Natural gas plants that were facing retirement are suddenly finding new life as backup power for data centers. Nuclear plants that were scheduled for decommissioning are getting lease extensions and even capacity upgrades. But the real action is in new generation capacity. Solar and wind developers are rushing to sign deals with tech companies for dedicated renewable power. Battery storage providers are seeing explosive demand for grid-scale installations that can smooth out the intermittency issues. And here's the kicker. Some tech companies are even exploring bringing nuclear reactors back online that have been shut down for years. Amazon just announced a deal to develop small modular nuclear reactors specifically for data center power. Google is investing in geothermal projects. Microsoft has signed agreements for fusion power that doesn't even exist yet. These aren't just publicity stunts. They're strategic bets on technologies that could fundamentally reshape how we generate electricity. Now, what about the tech companies themselves? This is where the picture gets complicated. On one hand, they're driving unprecedented demand for their services. AI capabilities are becoming table stakes for every major technology platform, which means they have to keep building regardless of power constraints. But on the other hand, these power limitations are forcing them to make strategic choices they've never had to consider before. Site selection for new data centers used to be about fiber connectivity, real estate costs, and maybe tax incentives. Now it's primarily about power availability. Companies are literally choosing where to build their next AI facilities based on which locations can get them electricity the fastest. This is creating a new kind of competitive advantage. The tech companies that secure long-term power agreements and get their data centers online first will have a structural edge in AI deployment. It's not just about having the best chips anymore. It's about having the power to run them. Some companies are getting creative about this challenge. They're exploring on-site power generation, investing in their own renewable energy projects, and even developing new data center designs that can operate more efficiently in constrained power environments. The winners in this space will be the ones that treat energy strategy as seriously as they treat their core technology development. But there's another group that's emerging as potential winners, and they might surprise you. These are the communities and regions that position themselves as AI-friendly power hubs. States like Texas, Ohio, and parts of the Southeast are actively competing to attract data center investments by fast-tracking power infrastructure projects and offering regulatory streamlining. The economic impact is massive. A single large AI data center can represent billions of dollars in investment and hundreds of high-paying jobs. Local utilities see rate-based growth. Construction companies get multi-year projects, and the tax revenue can transform local budgets. However, this isn't without risks. Some communities are pushing back against data center development because of concerns about grid reliability and electricity costs for residential customers. There's a growing tension between the economic benefits and the infrastructure strain. So what does this all mean for the next 5 years? I see 3 potential scenarios playing out, and each one creates different winners and losers. Scenario 1. The bottleneck persists. In this world, power infrastructure development continues to lag behind AI demand. Utilities become the kingmakers, essentially deciding which companies get to expand their AI operations and which ones get stuck waiting. Power costs skyrocket. and only the largest tech companies with the deepest pockets can afford to compete at scale. Scenario 2. Infrastructure catches up. This is where coordinated policy efforts, massive infrastructure investment, and technological breakthroughs in power generation combine to meet the demand surge. Growth becomes more balanced, costs stabilize, and we see broader participation in AI development across more companies and regions. Scenario 3. Decentralization wins. Here, advances in on-site power generation, battery technology, and energy efficiency allow large AI deployments to become more self-sufficient. Tech companies build their own microgrids, invest heavily in local renewable generation, and essentially decouple from traditional grid infrastructure for their most critical workloads. The reality will probably be some combination of all three, varying by region and time frame. But here's what I'm watching to determine which scenario we're heading toward. First, the pace of power purchase agreements between tech companies and utilities. If these deals keep accelerating, it signals that companies are prioritizing energy security even at premium costs. Second, regulatory approval timelines for major transmission projects. Faster approvals means Scenario 2 becomes more likely. Third, announcements of on-site power generation projects. If tech companies start building their own power plants, that's a clear signal towards Scenario 3. The trillion-dollar energy rush is just getting started, and the companies that understand this shift and position themselves accordingly will be the ones that dominate the next phase of the AI revolution. Because when the dust settles, the winners won't just be those with the best algorithms or the most data. They'll be the ones who solved the fundamental challenge of keeping the power flowing to fuel artificial intelligence's endless appetite for electricity. The question isn't whether this energy crisis will reshape the tech industry. The question is whether you'll be positioned to benefit from the massive changes that are already underway.